The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Kaprockman-Taylor, and this is episode 12, Entity Framework Core. In this episode, I'll talk a little bit about what Entity Framework Core is and what it allows you to do. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. All CRUD apps require access to some data store or other. We need to create, update, read, and delete records in that data store, but how do we do it? It seems that Microsoft has created many different technologies in order to let us do just that. First, there was ADO.NET. This was a technology which allowed us to create an instance of the SQL connection class and perform arbitrary commands on a SQL database using the SQL command class, including possible SQL injection code too. Bobby drop tables, anyone? Using ADO.NET allowed us to read rows from the database via the read method on an instance of the SQL command class. This would read the values from the database row into an object array. The value for each column from the row is read and exposed as a string, but there are extension methods to attempt to read the values as certain types. For instance, getDateTime, getIn32, getGUID, etc. This allowed us to manually read each row in a POCO, or a plain old C# object. However, it was a slow, arduous task. If you did a select for the first 100 rows, for instance, you would need to attempt to read from the reader 100 times before you could close the SQL connection instance. And of course it was important to close the connection to the database for reasons which should be obvious. Then Link to Entities came along and made everything so much simpler. Unlike ADO.NET, which required an instance of the SQL connection and SQL command classes, Link to Entities used the idea of an object context. This was a wrapper around the connection to the database. The big innovation that Link brought was the ability to include SQL-like statements in code. Rather than wrapping a SQL command in a string and parameterizing scalar values, of course, you could literally type the commands into your C# or VB source files. An example of a Link to Entities-based query would be something like var query equals from books in context.books select new. Remember to check the show notes for the code listing I just read out because it'll be a lot more detailed. And this is a much simpler way of achieving the same goal. Entity Framework. So just what is Entity Framework and what's so great about it? Imagine being able to query your database without having to actually deal with creating instances of the SQL connection objects, and remembering to close and dispose of them, of course. Imagine being able to query your database as if it's some kind of in-memory collection of strongly typed class instances as well. Those 2 points are just some of the killer features of Entity Framework. Whereas previously we had to write all of our code for communicating with the database, as you saw earlier, and we had to manually script any schema changes that were required in order to reflect changes to the models. This is all taken care of for us by Entity Framework. With Entity Framework, everything revolves around the DB context class. This class represents all of the code required to communicate with the database. It also includes things like change tracking, so you can build up a large transaction of many database actions before committing it to the database. The DB context class requires a connection string and a range of DB set of type T properties, one per table in your database. But once those have been provided, you can query the DB context object with familiar Link to SQL or Link to Entities code in order to query the database and return pre-hydrated object instances back from it. EF allows you to use one of two different programming models, database first and code first. These both expose different ways for your application to work with a database. In database first, you connect Entity Framework to a database and it will aid you in creating a set of .NET models which represent the schema. I haven't used this EF model that much, but it can be really good at querying a pre-existing database, or if you have a DBA who can draft a schema for your project. Then there's code first, With CodeFirst, you create a collection of .NET classes which represent the schema that you want, and EF will generate and run the scripts required to set up that schema in the database. This can be great if you have lots of experience with .NET, but not very much experience with your chosen database technology of choice. That sentence isn't meant to be offensive in any way, just some folks have more experience with .NET than they do with database engines, that's all. In either of those two, both Database First and Code First, there will come a time when your .NET models will have to change. This could be for a range of reasons. Perhaps a new feature is requested, and more data needs to be stored. Maybe a field needs to be removed from a table. Maybe you need to enforce data type limits. You may want to enforce some kind of validation at the schema level, for instance. Either way, your database schema will need to be migrated to represent those changes. In the old days, we had to manually write the migration scripts ourselves. Then we'd have to rewrite them because we'd probably forgotten some field or other, or gotten the database into some strange situation. Entity Framework can abstract all of that away, as it can detect when those migrations have happened. Essentially, it compares the schema with a DB set of type T instances which represent that schema. When it detects that changes have happened, it can either automatically migrate the schema to reflect those changes, or it can provide you with scripts so that you can migrate the schema differently. Both auto and manual migrations have their place, but I tend to prefer manual migrations. In auto migration mode, when EF detects that there is a mismatch between the schema and the DB set of type T's reflected in the DB context, it will automatically and this is the important part, silently alter the schema in order to match the new DB set of type T instances and their relationships. No system is foolproof, and mistakes can happen. By enabling auto migrations, you run the gambit of EF intuiting your changes incorrectly and leaving your database in a state where it's unusable. That's why I prefer manual migrations. In manual migration mode, when EF detects that there is a mismatch between the schema and the instances of the DB set of type T's reflected in the DB context object, it will throw a runtime error and will force you to manually migrate the database schema. Manual here is a bit of a misnomer because EF will still help you by generating scripts required to migrate your database, but you'll have to run them manually. All of that's a bit complex, so let's have an example. Let's say your database schema represented in the DB context with the following two classes. I'm going to read some code out here, obviously. I would check the show notes at .NETcore.show to see the full listing and all of the comments that I've added. I'm not going to read the comments. Well, let's say you have two classes, a user class with an int user ID, a string username, and an int shipping address ID. And let's say you have a shipping address class with an int shipping address ID, string address first line, and an int user ID. Hopefully you can imagine the database schema which will represent these two classes. Each class has a virtual member, the shipping address has a virtual user, and the user class has a virtual shipping address. The virtual keyword is used here to help EF to figure out which tables map to which tables through their foreign keys. Now let's say that you want to add a new property to the shipping address table called zip code. Well, you alter the shipping address to add it, then tell EF that it needs to migrate the schema. The altered shipping address class could look something like this. Again, I'm going to read some code out, so check the show notes. Your shipping address class could now have a public string zip code property. Then, depending on whether you are using Visual Studio or the .NET CLI, the command you need to run to tell EF that there is a migration to add will be slightly different. Here is the command for adding a migration from the .NET CLI. .NET space EF space database space migration space add space and then name of your migration. Again, check the show notes. This will scaffold a new class called added zip code shipping address, or whatever you call it, which will have two methods, up and down. The up method is used to update your database and add new features to the schema, whereas the down method can be used to undo them. The contents of the added zip code to shipping address should look something similar to the following. Again, I'm going to read some code out, so check the show notes for a full listing. You'll have a public partial class called added zip code to shipping address, which extends migration. You will have a public overridden void up, which takes a migration builder. In that method, the migration builder will simply add a column of type string with the name zip code to the table shipping address. There'll also be an override void down, which also takes a migration builder, and that migration builder will just simply drop the column. Once you've given the migration code the once over and made sure that it reflects what you want it to do, you can force EF to apply the migration by running .NET EF database update. This will force EF to convert the contents of the up method into SQL and apply it to your database. But what about querying? As I said earlier, you can access the DB context object and query any of the tables that you find there using link to SQL or link to entities. Let's say you have a method on a user service which is used to search for a given user's shipping address entity. The following may not be the best or most efficient way to do it, but it will do for the example I'm trying to make. The method may end up looking like the following. Again, check the show notes for the full listing because there's lots of comments in it. You'll have a public class called user service which takes a DB context, and in there'll be a public method called getShippingAddress for user ID which returns a shipping address and takes the user ID as an integer. You'll call dbcontext.shippingaddresses.first.default and pass in a lambda of shippingadder goes to shippingadder.userid equals userid and return the value. The link statement in the previous example method will be translated into something which matches the following SQL. Select from dbo.shippingaddresses as shippingadder, where shippingadder.userid equals and then the target user ID. The actual SQL won't match because EF will do some things in the background to make the SQL more performant, like using short scalar values and such. The most important thing to remember is that EF will utilize Link's deferred execution model. Hey everyone, sorry to interrupt. I hope you're enjoying the episode. Just thought I'd let you know that if you connect with me on Twitter and send me a message saying which episode you heard this announcement on, I can get you a 40% off code for anything on the Manning publication website. That's both books and the video courses. Anyway, on with the episode. But what's deferred execution, Jamie? Because connecting to a database, running a query, parsing the results and hydrating them into POCOs takes time, EF uses deferred execution. This allows you to run the query and get the response when you actually use the response, rather than when your link code is interpreted at the IL level. All of that is an incredibly roundabout way of saying that EF will not actually run the generated SQL when you call getShippingAddress for user ID from above. It will only run the SQL when you actually use the values in the returned model. Here's an example using the user service from our previous example. Again, check the show notes because I'm about to read the code out. So let's say you have a public class controller called userController. That userController has a user service injected in. You have a public action method, getZipCode for user, which returns a string but takes an int user ID. Let's say you have a var shipping address entity which is equal to the return from the user service's getShippingAddress for user ID method, and then let's say that you are returning from your controller method the shippingaddress entity.zipcode. Again, check the show notes because there's lots of comments in this code. EF will only actually access the database via the DB context when we call the property accessor, that's the official name for the dot operator, on the entity that we returned from the service. This is a very important distinction and is something you need to remember as you start to work with Entity Framework. Change tracking. Let's say that you start making updates to tables. Well, EF keeps track of all the changes that you make to any fields on any of the things reflected in the DB set of type T objects. Again, that's really complex, so let's have another example. Let's say that you create a method to update the user's zip code property. Remember that EF will not run the actual SQL until you access the properties of the returned entities. Again, check the show notes because I'm going to read out some code. You have a public async method called updateZipCode for user which returns a task of type int, takes in a user ID and a zip code. First thing you're going to do is get the shipping address. With our previous example, we use dbcontext.shippingaddresses.first.default, passed in a lambda of shippingadder.userid equals userid. Then we're going to call .zipcode on that and set it to the value that we've passed in. And then we're going to tell dbcontext to save the changes by calling return await dbcontext.savechangesasync. Again, check the show notes because the comments in this code block are really illustrative as to what's happening. Each time that you query the DB context object, EF will make a note of the entities that you've accessed. This way, when you call save changes, or more likely save changes async, it knows which tables to run update queries on. Without this, EF would not know which tables and entities that it needed to update. If you're doing read-only queries, you can tell EF not to worry about tracking any changes by using something like this: dbcontext.shippingaddresses.asNoTracking.first.default, pass in a lambda, which is shippingadder goes to shippingadder.userid equals userid. This tells EF we're not going to be making any changes. As such, the next time that we call save changes, or again save changes async, EF will not know about any changes that we've made to any values or entities that we've asked for. It will also not bother to try and write a SQL query to update those values. Wrapping up. Although EF and EF Core are incredibly simple to use, they can be quite complex under the hood. EF Core is arguably faster than EF, but it has fewer features than its older sibling. I didn't have much time to touch on it, but EF Core doesn't do things like lazy loading because, and I'm quoting Julie Lerman here, a lot of folks get it wrong. Entity Framework, regardless of whether you use the original version or the core version, can make querying databases incredibly easy and simplifies a lot of the common stuff that we do with our CRUD apps. Using EF when you don't know a lot of SQL can make the developer experience of interacting with the database a lot simpler, and can be a great way to get up and running very quickly. There's a lot more detail to EF and EF Core that I've intentionally left out of this episode. EF can get quite complex, but I've covered the basics in this episode and I'll provide links in the show notes to learn more. Head over to .netcore.show or check your podcatcher for a link. Hopefully you found this interesting. If you did, then let me know by sending me a tweet at .netcoreblog, or head over to the website dotnetcore.show and let me know what you think. Remember to check the show notes for a full link to the transcription of this episode, which also has links to a bunch of related websites and resources. This is available at .netcore.show. And don't forget to spread the word. Leave me a rating or a review on your podcatcher of choice. And remember to come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks.